So just a few slides to show our robot in action. The problem we're going to be doing is visual teach and repeat. So the robot's going to be teleoperated along this initial training route, and then afterwards it's going to recapitulate the route. This is with 3 different versions of the algorithm. Just to show the kind of robustness. What we can see is that the robot, all the computations are happening on board the robot. It's a small robot. It's got a Jetson TX1, I think this was. And it's running off some small AA batteries, doing all the visual processing, which is fairly minimal, and all the comparisons. It follows the route reasonably robustly. It doesn't follow exactly, follows the general sort of pattern of the route. It's not bothered by people going past it, so it's follows the overall thing, and is very robust to people walking past it, to visual noise. The route is not particularly smooth, and it recapitulates it quite happily in these different situations. So the reason it doesn't care about people, we see in the next slide, we see the view from the robot. So this is the view of the panoramic camera. Important thing to note here is, watch when this person walks past here. They barely appear in this panoramic view, and with our human-centric vision, these people are really salient, but to the panoramic camera, it doesn't really matter. The important thing to note is that the big changes in these viewpoints is when the robot rotates, as it did then, and then that's what we use in our algorithms. And something called the visual compass. So to set a direction from a panoramic image is very robust. It's very good. The other point to note is that all the information is in the skyline. So objects above the sky is where all the big cues are in this world. So that's why a UV camera would be very good. And it's again taking inspiration from ants to be able to do this task.